third and final video of the day. It is dividing rational expressions. So on the third tab, next to the circle number 3, you need to write dividing rational expressions. Our steps are very similar to the last 2 pages. However, our second step on this one is going to differ slightly, and we'll talk about that. Our first step is to factor. Whoops. So we start by factoring. Our second step is where we differ. Let me explain why before I explain how we differ. So, if we look at this basic example, and we think back to how we divide fractions. Remember we have to do that keep, flip, change thing? Or, as some of you might know, we have to multiply by the reciprocal. So, we're going to change this into 2 over 3 times 5 over 9. And then we would multiply like normal and get 10 over 27. The important part that I want you to notice is which numbers are on the denominator at any point during this problem. So we have, this is in the denominator, in the same spot in both times. This one starts in the denominator and ends up in the numerator. And this 9 starts in the numerator but ends in the denominator. At any point, a fraction cannot have a 0 in the denominator. So even though our 9 starts as a numerator, it becomes a denominator. So whatever this is, it can't be 0. Even though this 5 becomes a numerator, it starts as a denominator. So again, it can't be 0. We are going to use that idea to find our excluded values. So when we're looking for our excluded values when we are dividing, we have to set both denominators, like before, set both denominators and the second numerator. Oops. Equal to 0 to find excluded values. So that's where we differ. That we're going to be setting that second numerator equal to 0 as well as both denominators in order to find all of our excluded values. Our last step here is to cancel and simplify. So let's look. We only have 2 examples. First one, we got to start by factoring. So we are going to factor, 7x doesn't factor. It's going to stay the same. 2x minus 10 does factor. I can pull out a GCF of 2. So I'd have 2 times x minus 5. I'll keep it as divided for now. I could change it to a multiplication and flip it. It wouldn't make a difference, but I'm just going to leave it alone. I can pull out a GCF of an x. So, oops. So I'd have x times x minus 6 over, factor this, I get x minus 6, x minus 5. Now I need to find all of my excluded values. So 2, I'm not going to set equal to 0 because 2 will never equal 0, so that just doesn't work for us. That's not going to prevent anything. But I need to set my x minus 5 equal to 0, x minus 6 equal to 0. I don't need to set x minus 5 equal to 0 twice. I also don't need to set x minus 6 equal to 0 twice. I do need to set that numerator in the second fraction, that x, equal to 0. I don't have to set that 7x equal to 0, because if I look back at my previous one, this numerator, that first numerator, never becomes a denominator. It's always going to be a numerator. So it's never going to cause me an issue with an undefined expression. So I can leave 7x alone. That's not an issue. Go ahead and solve. And x equals 5, x equals 6, and x equals 0. Now, I need to go through my process of actually multiplying these fractions. So I'm going to use my keep flip change and have 7x over 2 times x minus 5 times x minus 6 times x minus 5 over x times x minus 6. Then my x minus 5's will cancel, my x minus 6's will cancel, and my regular x's will cancel. So I'm only left with 7 over 2, where x cannot equal 5, 6, or 0. Let's look at the last example. Woohoo, we're almost done. Move that out of my way. Come on. All right, so the last one. Yes, 2x squared plus 3x minus 5 does factor. If you don't know how it factors, there is an IXL assignment called Factoring Quadratics that could help you. There's also some IXL assignments, I think they're either called when a does not equal 1 or when a is greater than 1 or something like that, that will also help you. If you want some extra practice on these types of factoring problems, just shoot me an email and I will happily send you some extra practice problems. So, when I factor 2x squared plus 3x minus 5, I get 2x plus 5 and x minus 1. Let me make sure that's true. Yes. Okay. Over 6x divided by, again, this needs to factor, and I need to make it into a fraction. So I'm going to put it over 1. So I can pull out my GCF of x, and I have 2x plus 5 all over 1. Just like in the last problem, I need to take care of any excluded values. So I'm going to do 6x equals 0. 1's never going to equal 0, so I get to skip that one. X equals 0, and 2x plus 5 equals 0. Solve. So I have x equals 0 twice, which is fine. And x equals negative 5 over 2. I know, my 5's are starting to look like s's. Sorry. 5 over 2. All right, so then I can do my keep flip change or multiply by my reciprocal. So 2x plus 5 times x minus 1 over 6x times 1 over x times 2x plus 5. 2x plus 5 cancels, and nothing else does. These x's, the 6x and this regular x, they're both in the denominator, so they're not going to cancel out. I can't take out just this x from this x minus 1 because that's a pair with a binomial. I can only do something if I have another x minus 1. So I'm just going to multiply straight across, and I get x minus 1 over 6x times x, which is 6x squared, where x cannot equal 0 or negative 5 over 2. That is the last of the problems that you need to take in your notes today. Please make sure that you keep this foldable in a safe place so that we can continue working on the last 2 pages of it when I get back. From here on out, the rest of the class period, You need to work on the 7-3 practice so that you know what questions you need to ask me when you come back. And you need to work on your 7-2 assignment if you're not finished with it, because you will have that homework quiz on Monday. Please remember that if you have questions about that 7-2 assignment, you need to come see me outside of class. We're not going to have time to answer questions before the assignment on Monday. If you need anything, send me an email, and I hope you have a wonderful weekend. Oh, I'm pressing the wrong things. Hang on. Sorry.